So this problem is about the motion of bodies when gravity is involved. So two bodies were thrown simultaneously from the same point, one straight up and the other at an angle of theta equal to 60 degrees to the horizontal. Okay, the initial velocity of each body is equal to v naught equal to 25 meters per second. So both the initial velocity magnitudes are the same. Neglecting the air drag, okay, find the distance between the bodies some t equal to 1.7 seconds later. I will write. So basically there's one body which is thrown straight up with initial velocity of magnitude v naught, and another body that is thrown at an angle of some theta to the horizontal with the same magnitude v naught. Okay, and we have to find out the distance between the two bodies after a certain time t later. Okay, so now if we consider body 1, so body 1 is obviously just moving in the so let's say this is the x axis, the horizontal direction, and vertical, let's represent it by y. Okay, so basically the first body is not moving at all in the horizontal direction, so let's represent it by the displacement in the x direction. Let's represent it by s1x, so that is 0 obviously. Now we need to see what happens in the y direction. S1y is equal to, so we have the, from kinematics we already know the equations that relate basically the initial velocity, the acceleration, and the displacement after some time t. So that is nothing but ut plus half at square. So s is equal to u is v naught into, sorry, so v naught t plus half. So acceleration is, so yeah, acceleration a, let's call it a, is actually minus g because it acts in the downward direction. Confusion is just remove it. It acts in downward direction, so it's in the negative direction. So half into minus g t square. This basically represents the position of the body 1 after time t. All right. Now if we consider body number 2. So body number 2, it has two components of velocities, one in the horizontal and one in the vertical. So v naught, so in the horizontal direction it is v naught cos theta, in the vertical direction it is v naught sin theta. Okay. Yep, so let's see. So in the horizontal direction the acceleration is 0 and there is no air drag, so it's basically constant velocity in the horizontal direction. So s2x is nothing but just, and also one more thing that I should have mentioned is the origin of this O is basically the point at which both the bodies are thrown. That's the origin. Yeah. So s2x will just become v naught cos theta times t, and s2y is nothing but, again we'll use the equation ut plus half at square, and here also the acceleration is minus g. The initial velocity in the y direction is v naught sine theta into t plus half minus g t square. So the distance between the two, okay, so see, so the distance between body 1 and body 2 after time t is equal to, so we know their axis positions and their y axis positions. So basically by Euclidean geometry we can say that the distance is nothing but root over s1x minus s2x whole square plus s1y minus 2y whole square. Just substitute the values here. So s1x is 0, s2x is v naught cos theta t, v naught cos theta t square. S1y is v naught t minus half gt square, and s2y is v naught sine theta t because this is a negative sign and minus of minus becomes plus, so half gt square. Now it's minus plus cancels out, so you basically have v naught square cos square theta times t plus v naught t minus v naught sine theta times t whole square. So if we open up the square term, v naught square cos square theta t plus v naught square t square plus v naught square sine square theta t square minus 2 v naught square t square sine theta. Okay, this becomes root over, so this term and this term can be added together because cos square theta plus sin square theta equal to 1. That gives you v naught square. Okay, I'm sorry, they cannot be added because here's a t and here's a t square. Okay, I'm so sorry, this is t square, this is also t square, sorry for that. So these two terms can be added, so cos square theta plus sin square theta is 1 and it becomes v naught square t square. So these two join to become v naught square t square, this is also v naught square t square, so twice v naught square t square minus twice v naught square t square times sine theta. So basically gives me, so I can just take out v naught t times root over 2 into 1 minus sine theta. So this is basically the distance between body 1 and body 2 after time t, which is v naught t into square root of 2 into 1 minus sine theta. So you can now substitute the values of v naught, t and theta essentially, and you can get the answer. So this v naught into t into root over 2 into 1 minus sine theta matches with the Irodov answer. Okay, that's that. Thank you.